Okay, now we're going to be adding, subtracting, dividing radical expressions. The first one is adding and subtracting like radicals. Well, you've got to go back to, if you remember, in chapter 5, we had something like 3x plus 7x. Those are called like terms, and we can combine by adding the coefficients. Well, the same game goes here. These are those are like terms, these are like radical terms. So I've got the same square root of 2, so I combine their coefficients. So that would give me 12 square root of 2. And that's my answer on that one. Not bad. This one, it's understood to have a 1 here, and like we had subtraction back when we had like terms, well, we can have subtraction here. I've got 1 minus 7. That would give me a negative 6 square root of 5x. What's going on here actually is that we're factoring out the square root of 5x, and if I do that, that's what allows me to go ahead and just combine the coefficients. Now, these are not bad, but they do play games. If you'll notice in the next two parts, the first thing you've got to do is, if the radicals aren't the same and you're being asked to add or subtract, then you're going to have to rewrite them as simplified radicals. And this is what we did in the very last section before I can do anything. So this one's as far as I can go, so let me leave it. 12, well, 12 has a perfect square factor. Now I've got like radical terms, so that would give me a 9 square root of 3. Well, this one is a slight mess. Let's see what we can do. 50, I'll start there. I've got a 25 times 2x. Now sometimes what's on the inside of the one that you can't do anything with, or the one that you've already started, will give you an idea what you have to do with the other one. Sometimes, maybe 8 out of 10 times. But this one, if I need to have a 2x left, it looks like I'm going to have a 16. So that comes out as 5 square root of 2x, 6 times 4 square root of 2x. 4 times 5 is 20 square root of 2x minus 24 square root of 2x. So now it looks like I've got a negative 4 square root of 2x. So if you're asked to add or subtract, the radicals must be the same to allow you to combine those coefficients. Now, the title was adding and subtracting, so we've done that. So now we got to look about dividing. My quotient rule. If A and B represent non-negative real numbers and B does not equal 0, then if I have square root of A divided by square root of B, that's the same thing as square root of that fraction. Or if I have the square root of a fraction, then I can separate square root of A divided by square root of B. So sometimes it's to your advantage to go ahead and put them together and simplify the fraction and then do the square root if possible. Let's see what we've got down here. I've got square root of 24 over square root of 12. If I go ahead and put them together, 24 divided by 12, which is square root of 2. So that's my answer. Let's see about this one. That would give me square root of 9, and I can simplify that, whoopsie, all the way down to 3. Now this one I can't divide, but let's go ahead and we can separate. Square root of 100 is 10 and square root of 9 is 3. See about this one. I'm going to put them together. Let me simplify my fraction. That will give me an 8x squared, and that looks like a problem that we had just in the very last section. Make yourself a dot. See, I know the x squared is going to come off. Break 8 up to where it's going to have a perfect square factor. And then these two get to come off. Or come out. I always thought that looked like a bus to me when I first saw these. So I let them come up here and they get to come off the bus. But anyway, that's it for this section. Thank you.